directly talk about with our 2D vectors. So we're going to ask you to find what are referred to as direction angles of a vector. Every vector in space has 3 direction angles associated with it. All direction angles they're the angle between the vector itself and one of the 3 axes. Okay? So let's say we're working with vector v here. It has 3 direction angles, alpha, beta, and gamma. Right? Alpha, beta, and gamma. Alpha is the angle between vector v and vector I. Now recall, vector I is just a standard unit vector along the x-axis, right? So all we're really saying is this is the angle between the vector v and the x-axis, okay? Now you can look at the picture here, and this is the angle we're talking about when we are referring to alpha, all right? Beta, we're defining to be the angle between vector v and vector j, where j is that unit vector along the y-axis. So now we're referring to this angle right here. And then gamma is the angle between vector v and vector k, where k is along the z-axis. So this is our gamma. All right. Okay, now we have 3 formulas that are essentially derived from this previous formula right here, used to find the angle between any 2 vectors. Okay? So think of these are kind of like shortcuts, all right? If I want to find the angle between vector v and the x-axis, so that's again angle alpha, cosine of that angle alpha is going to equal nothing more than a divided by the magnitude of vector v. Now notice where a is coming from. A is this scalar on the unit vector I. Okay? Now if I want to find beta, cosine of beta would equal b divided by the magnitude of the vector. And wild guess, what do you think cosine of gamma is going to be? C divided by the magnitude of the vector. Make sense? All right, now I want to derive one of these for you. Okay? And once I derive one, you'll be able to see how I would get the other 2, okay? So let's say I want the angle between vector v and vector I. Okay, now recall, vector I really means 1i plus 0j plus 0k. So keep that in mind. All right? Cosine of this angle, which we're going to call it alpha, to be consistent with the definitions above. So cosine of this angle is supposed to equal the dot product between vector v and vector I divided by the product of their magnitudes. Okay, well, the dot product of vector v and vector I is going to be a times 1 plus b times 0 plus c times 0. All over, I'm going to leave that as the magnitude of vector v. And then what's the magnitude of the unit vector I? The magnitude of the unit vector I. What's the magnitude for any unit vector? 1. So notice what this simplifies to. A plus 0 is just A divided by the magnitude of vector V. So that's where these shortcut formulas come from. Okay, so let's find the direction angles for this vector V equaling 3i plus 2j minus 5k. So we need the magnitude of the vector first and foremost. It's going to be the square root of 9 plus 4 plus 25. So that's the square root of 38. So if I want the direction angle alpha, that's going to equal inverse cosine of 3 divided by the square root of 38. See what we get. $60.9 degrees. So again, understand what that measurement represents. That is the angle between this vector V and the x-axis. The x-axis. Bless you. Okay, now we get beta. That would equal inverse cosine of 2 divided by the square root of 38, where 2 is the scalar on J from vector V. So let me just change that right there to a 2. I'm getting 71.1 degrees. That's the angle between this vector V and the y-axis. And then let's get gamma. Inverse cosine of -5 over the square root of 38. Now that's going to be larger than 90 degrees because that's a negative number. 144.2.